Okay, in this video, what I'm gonna do is I'm gonna teach you a simple method to find the hybridization of atoms. And the way to do is actually by finding the number of groups attached to the atom you are trying to find the hybridization of. So whenever I say groups, what that means is we're gonna count the number of lone pairs and number of atoms that's connected to that the particular atom. So if you have altogether of two groups, that means it would be sp hybridized. If there is three groups, it would be sp2, and if there is four groups, it would be sp3. So to understand that better, let's go ahead and take an example. And the first example is ethane. That means if you draw the Lewis structure of the ethane, it will look something like this. So let's go ahead and find the hybridization of the carbon right here on the right, on the left. So to find the hybridization, as we learned earlier, we need to find the number of groups connected, and to find the number of groups you have to count the number of lone pairs and number of atoms the carbon is connected to. So here we don't see any lone pairs, that means lone pairs is 0. So if we find the number of atoms it's attached to, let's go ahead and count that. It's connected to one hydrogen, connected to another hydrogen, it's connected to another hydrogen. That means it's connected to 3 different hydrogen atoms. Alright, and then that's not all. And if you see here, there is a bond between carbon and carbon. That means this carbon is connected to the carbon on right here. So it's connected to 3 different hydrogens and 1 carbon. So in total it's connected to 4 different groups, and then it has 0 lone pairs. So if we add them up, 4 plus 0, that would be 4. So which means the hybridization of the carbon is sp3. Alright, let's take another example for ethene. It's the same compound. Okay, sorry, we're missing here, let's say we're missing the hydrogens here. Let's go ahead and add some hydrogens. Okay, that's how the structure looks like. So let's find the hybridization of the carbon right here. So we'll do the same thing. First let's go ahead and count how many groups it's connected to, and to do that, first count the lone pairs. So we don't see any lone pairs, so that means 0 lone pairs. And if we have to find the number of atoms, we have to go here and count. It's connected to one hydrogen here, it's connected to another hydrogen, and this carbon is connected to another carbon on the left through a double bond. That means it's just connected to another carbon on the left. So altogether 2 hydrogens and 1 carbon. So that means it's connected to 3 different groups. So if we add 3 and then 0, that will give us 3. So altogether the number of groups connected is 3, which means this is sp2. Alright, so now let's go ahead and take another example for ethane. So the Lewis structure for ethane looks like this. There is a triple bond between carbon. So if we have to find the hybridization of the carbon on the right here, we do the same thing, finding how many lone pairs and how many atoms. So lone pair, same thing, carbon, so there is 0 lone pairs. So number of atoms, hydrogen 1 is connected to another carbon by triple bond. So number of atoms this carbon is connected to is 1 hydrogen and 1 carbon. That means altogether of 2. So if we add 0 lone pairs and 2 atoms, that will give us the total number of groups this carbon is connected to, which is 2. So if it's 2, we know from the table above it's sp hybridized. Alright, after this let's go ahead and take another example. The simplest molecule we see everywhere, water. If we actually draw the Lewis structure for water, it looks like this. So here we have to find the hybridization of oxygen. in the middle, or the center atom. So to find that, we have to first find the total number of groups it's connected to, and to find total number of groups we need to first find the total number of lone pairs oxygen has. So it's different than the carbon earlier, because oxygen here has lone pair. So oxygen has one lone pair here, another lone pair here, so that means it has two lone pairs, and then it's connected to one hydrogen on the right here and another hydrogen on the left here. So it's connected to two different hydrogens and has two lone pairs, so that means two lone pairs, two hydrogens. So if we add them up, that would be 4. So if it's connected to 4 groups, it would be sp3. Alright, now let's move to another compound, carbon dioxide, simplest molecule. If you draw the Lucy structure, the one is over here. So let's find the hybridization of carbon. So we do the same thing, find the number of lone pairs, which we don't see here. So lone pairs is 0, and then we have to count the number of atoms it's connected to. So on the right it's connected to one oxygen, and on the left it's connected to another oxygen, that means 2 atoms. So if we add 0 lone pairs and 2 atoms, that will give us 2, and if it's 2 groups, it's sp. Alright, so the last molecule we'll take the example is here, formaldehyde, S2CO. So if we draw the Lucy structure, it looks like this, S2CO. So we have to find the hybridization of carbon right here. So we do the same thing, find the total number of lone pairs, which is 0 here, and then find total number of atoms it's connected to. Oxygen here, that's first atom, and hydrogen here, and hydrogen here. So that means this carbon is connected to one oxygen, one hydrogen, two hydrogens, one here and one here. So altogether connected to 3 different atoms, which means the hybridization is sp2.